The idea of a linear programming problem is that we've got some function of x and y, like this z function, and we want to find what's the either biggest, or in this case the smallest, that z can be over this region right here. So the first thing to do is graph this region. So we've got this 2x plus 3, and we'll set it equal to 30. 2x plus 3y set equal to 30. And make a table of values with 2 points. I like to use the x-intercept and the y-intercept. So for the y-intercept, let x equal 0. Find out that y is a 10. Next, let y equal 0. And then we'd have 2x equals 30. So 15 for x. And then start graphing. So a 0 and 10 for the y-intercept, and then 15 and 0 for the x-intercept. And then this part right in here says that x and y should both be bigger than or equal to 0, which means we're just going to be using the first quadrant. So we really just need this much of the line in the first quadrant. Okay, move on to this one right here, 3x plus 2y. If that was set equal to 30, make a small table of values. If x were equal to 0, then y would be a 15. If y were equal to 0, then x would be a 10. So it's actually switched the roles of the 10 and the 15. So 0, so this one will be in red. 0, 15 on the y-axis, and then 10, 0 on the x-axis, and again use a solid line, and just in the first quadrant. And then there's also x plus y equals 15. So x plus y is a 15 is going to be, let's see, a y-intercept of 15, and if y is equal to 0, then x is 15. So then that's going to be this point right here, 0, 15, connected to this point over here. Okay, now according to this, it needs to be, for that one, it needs to be less than or equal to it. So that means that it needs to be, for the last line that I just drew, it needs to be below it, which confines everything to this region in here, up to and including that line that goes from 15 to 15. And then as far as these, we can test. For example, this was the red one. So pick a point like 0, 0 to test. Should it be under the red line or above the red line? And if you test 0, 0, it's going to say, is 0 bigger than or equal to 30? And the answer is no. So it's not supposed to be on this side of the red line. Instead, it should be on the other side. Well, that means that it's going to be above the red line, but it has to stop at this 15, 15 line. So far, the region that we're talking about is this, which I'll just shade lightly because it's not going to be the final answer. Because we still need to go back, and for this black line, which was this one, we need to test 0, 0 as well. Or some other point, but 0, 0 just seems to be the easiest. So 2 times 0 plus 3 times 0, is that bigger than or equal to 30? And again, the answer is no. And so instead of being on this side of this black line, so instead of being on this side of the black line, it needs to be on that side. So this side underneath the black line is not correct. Luckily, I've got an eraser. Okay, so now we have the region that's being talked about. The region is this triangle Now for the next part, what we do is take all of the vertices of the triangle and take the x and y value, substitute it in, and see which one gives us the smallest result for z. That means that we need to know where is this point of intersection. So where do the black and the red line intersect? So now we need a system of equations that the black line 2x plus 3y equals 30, and this one 3x plus 2y equals 30. Where do they intersect? And for this, I believe I'll use elimination of the x's. So this needs to become a negative 6x, so multiply by negative 3. And this one needs to become a positive 6x, so multiply by a positive 2. So this is negative 6x, positive 6x, they cancel. Then distribute this as negative 9y, and positive 4y is negative 5y. And for the constant, it's going to be negative 90, and positive 60 is negative 30. And then divide to get that y is equal to a 6. And then take a look at the picture and see if that makes sense, that the y value is 6. So right about here would be a 6, which is definitely possible. Okay, good. And then take the 6 and go back and put it into one of the equations. I'll use this one. So 2x plus 3 times 6 equals 30. So this is an 18. Subtract 18 from both sides. So and then divide. X is equal to 6. So that's at the point 6, 6. So we finally have the region well defined. Now the next part is take the 6, 6, the 15, comma 0, the 0, comma 15, take those 3 points and substitute it into the z function. So I can then say, I can even make a little table of values with x, y, and z. So we've got this point 0 and 15, this one 6, 6, and then this one 15, 0. Substitute those into the z value, and this one's going to be x, and then double the y value, makes a 30. And then x plus double the y value is a 12, and 6 makes 18. And then x plus double the y value is a 15. And so we have it. The minimum is a 15. So a minimum of 15 at 15, 0.